Hi everyone, so continuing our work with moments, we're going to have a look at systems on the point of tilting, and you'll see my ingenious props here, a couple of bits of staples which are representing my supports, and a ruler which is representing a plank of wood or a uniform rod or a non-uniform rod, whatever it might be in the question. Okay, so if this is in equilibrium, imagine this is vertical, is standing up. If this is in equilibrium, then the rod is sitting on the two supports, wherever they might be. If it's uniform, presumably in the middle, otherwise one way or the other. But the rod is sitting on here, and if it's in equilibrium, we'll have our two reactions acting upwards and a weight acting downwards, or a couple of weights acting downwards, and nothing's happening. It's trying to turn one way or the other. We've got some moments happening, but if it's in equilibrium, it's staying there. If a force is applied, let's say, I don't know, at this end, so if I pull down at this end, what's going to happen, depending on how big this force is, we might get to a point where the rod tilts about this point, okay? So you get what's called tilting, okay? And if this happens, if it does tilt at this point, if it tilts at this pivot point here, then the reaction here obviously is now zero because this isn't touching this pivot point anymore. This isn't touching this support. So we've gone from a situation where we had reaction at two supports to, if it's tilted, we've still got reaction here because the rod's still touching this support, but here there's nothing happening, it's not touching, so the reaction's definitely zero. Now what happens as I put a force here, it's trying to tilt about this point, so even if it doesn't, the reaction here, if I add a force here, the reaction here is going to become less and less and less as it's getting closer to the point of tilting, so as I'm putting more weight on here. And when it's at the point of tilting, we've just got to that position where it's about to come away. At this point, it hasn't quite done that. It's on the point of coming away. So what's happened here is the reaction is actually reduced to zero. And then once it gets to zero, this is going to do this. So it's on the point of tilting, as it's about to go, the reaction here is zero. And that's going to be really helpful when we're looking at questions on this. So let's have a look at an example, and then I'll ask you to do some work on this in today's lesson and one of tomorrow's lessons. Okay, so I'll just make sure that's in shot. So here's our example for today. A uniform plank of mass 10 kilograms and length 4 meters is in equilibrium in a horizontal position. So first of all, we've got uniform, so we know our weight's going to be acting at the centre. It's resting on two supports, C and D. We've got some information so we can draw a diagram. We've got a buoy of mass 30 kilograms standing at some point E, and it's on the point of tilting about D. So again, that's really important in my question, and we'll draw the diagram and have a little think about what that means. So let's get our information on our diagram. So we've got a uniform plank, AB, and our total length is 2 meters. It's got mass 10 kilograms, and that's uniform, so that's going to be right in the middle here. So let's get that on there to begin with. So we've got a weight of 10g acting downwards, and then this is going to be 1 meter, and this is going to be 1 meter because it's uniform, so that weight's in the middle. Okay. What else do we know? It's resting on two supports, C and D, where AC is 0.5 meters, so that's going to be there. So this is 0.5 meters, and so is this. So I'm getting all this information on my diagram, so I don't need to keep going back to the question. It's all in front of me when I'm doing my moments in a sec. AD is 1.3, so 1 meter to there, and then another 0.3. Doesn't need to be exact, obviously, but somewhere there is our support at D, and that's going to be 0.3 meters. Okay, so this is what's happening so far. Then we've got a buoy of mass 30 kilograms standing on the plank at point E, and we don't know where this is, but it's on the point of tilting about D. So it's about to go there. The weight at the minute is this side, the weight of the plank. So the buoy must be standing over here somewhere for this to have any chance of tilting about point D. Okay, so if the buoy stood anywhere on this side of D, it definitely wouldn't be tilting about D. So it's got to be on this side, so we get this sort of action trying to happen. And we don't know where it is, that's what we're asked to find. So I'm just going to put my boy on here somewhere, and he's having this downward force, so let's call that point E. That downward force there of, what's it tell us, 30 kilograms, so there we go, 30G. So there's my diagram drawn. I haven't put my reactions on yet, so let's do that. So we've got a reaction at D, and we've got a reaction at C. And what do I know? I know that in this question, because we're on the point of tilting, this is actually going to have reduced to 0, because this is about to lift off C. So at that point, our C has got smaller and smaller and smaller. At the point of tilting, it's become 0. Okay, I'm going to take moments about D because it's tilting about D. So, our turning effect is happening here in this question. And also then that means that RD, this unknown reaction, I won't need to have in my equation because it's not having any moment effect, it's not having any turning effect at that point. And this RC I don't need to worry about because it's on the point of tilting about D, so this has gone to 0, we're about to lift off here, this has gone to 0, so that's pretty good as well. So let's have a look, telling the examiner, we're going to take moments about D. And what else? I'm going to take clockwise as positive. Okay, so let's have a look at this about D. This distance then, I don't know, so I'm going to call that X. So let's have a look at this. X and then this 30 about point D. So this is going to be clockwise. So that's going to be positive 30G. Perpendicular distance to D is X. And then I would have had this, from this point here, I would have had RC causing a clockwise motion as well, but this is 0 now, so I don't have any effect here because that's 0. I'm about to lift off here, so there is no reaction force there, so that's sorted. The only other thing then is the weight of the plank, the weight of the rod pulling down. And again, if I think about that, that's going to tend to make this system go anti-clockwise. So that's going to be minus 10G times my 0.3, which is my distance there, to D, perpendicular distance. And it's not actually moving yet. It's still in equilibrium. It's on the point of tilting, so it's in equilibrium. It's about to tilt. It hasn't happened yet, though, so this is definitely still 0. The moment's 0. Everything's about to move. It's on the point of going, but nothing's actually happening at the minute, so that's 0 there. Okay, so let's just sort this out then. So 30GX is 3G, taking that across. So X is going to be 0.1 metres. Let's make sure I've answered the question. Calculate the distance AE, so I want this whole distance from A to E. So that's going to be 1.3 plus my 0.1. That's going to be 1.4 metres in total. So this idea of at this point, because we're on the point of tilting, about point D, what does that mean? It means the reaction at C has gone to 0 at that point. It's been getting less and less and less as it's about to tilt. If it had tilted, not touching here at all, as it's about to tilt here, this is reduced to 0, and that's what helps us do this question. So I'm going to set you some questions on this from the exercise in the book, have a go at it, and then we'll move on from there.